Okay, so once again, hello. Since I asked you last time regarding the need for me to, give a lecture on the Cronin-Penny model, and I received the response from your side that you need an explanation of the Cronin-Penny model. So today I'll be discussing with you the Cronin-Penny model. Now, what this Cronin-Penny model is? Cronin-Penny model is actually used to explain the band formation in a crystal, and that is it is used to it explains the movement of an electron in a crystal. Now suppose we have an electron, but a free electron. So how do we visualize this free electron? Now what I have drawn here, these black dots which are visible to you, are the atoms which are in a crystal. These atoms can become ions when they lose the electrons and they become charged, right? Now this free electron, which has a very small mass as compared to these ions or these atoms, sees a potential barrier when it tries to move freely, right? So for example, this. So if an electron is moving, it sees a force created by this ion in its path. Then if its energy is greater than the potential which is offered by this atom, then only it will be able to overcome the potential and then continue its motion forward. Right. So in a sense, this electron, while moving through the crystal, observes a series of potential barriers which are placed at the regular intervals in a crystal along the three dimensions. Now, we've just, the author has just visualized these potentials offered by these ions as the potential wells, which have been marked here by an inverse parabola or a hyperbola. Now, we can use a simplified mathematical representation as shown in the another figure marked in blue as a train of potential barriers, as a train of potential wells. That is, we can have the spacing where there is no potential, and then we can have the potentials with a value of V0. Now it depends whether this electron will have an energy greater than V0 or this electron will have an energy lesser than V0. So in this case, two cases might arise. That is, whether the energy is less than V0 or whether the energy E is greater than V0. That is, we have two cases, whether the energy is greater than, energy of the electron is greater than V0 or energy of the electron is lesser than V0. So we have already discussed some of the problems before, that when the energy of the electron is greater than the potential barrier, it will be able to cross the, if the energy of the electron, if the potential barrier has an infinite energy, then the electron will be restricted only in this well. But if this potential barrier has a finite value, which is V0, this electron, there is a certain probability that this electron will tunnel through the barrier and it may cross this barrier. Right. So this is just for the simplification. So that is what we need to understand here, is that we need to have a solution. That is, we need to find out, that is, our problem is for finding solution of electron movement in the series of potential wells. Okay. So now we can have a simplistic approach to, the solution of this problem, and a simpler solution has been provided by the block, which is